Assalamualaikum and good day everyone. So as for today's lesson, we are going to take a look at the next subtopic, which is inverse Laplace transform. Okay. So before this, we had learned on how to get from ft to get your fs by using Laplace operator. Okay, and we also learned the properties of Laplace transform, which is linearity, phase shift, and also multiplying by Tn function. Okay, so now we are going to do a reverse process, which is from Fs to get your Ft by using Laplace inverse. Okay, so if Laplace of Ft is equals to Fs, then the inverse Laplace transform of Ft is given by this one. Laplace inverse of Fs, you will have Ft. So we are doing the reverse process. Okay, before this, from Ft to Fs by using Laplace operator. So now from Fs to get your Ft by using inverse Laplace transform. Okay, so take a look at this one. So Laplace inverse or inverse Laplace transform, this is an operator for inverse Laplace transform. Okay, this is not equals to 1 over n. Okay, so as for a start, we will take a look at this single function on how to get the Laplace inverse of each of the following function by using table of Laplace transform. Okay, so as for table of Laplace transform, so now we will look from this column to this column. Okay, before this, from Ft to Fs, so now reverse, so from Fs to Ft. Okay, so you have to identify the given function to you is in which form, either this one or this one. Okay, so let's start with the first function. If your fs is equals to 6 over s to the power of 4, fs is equals to 6 over s to the power of 4. Okay, so now take a look at this table of Laplace transform. You compare what you have and what's in the table of the Laplace transform. Okay, so as you can see here, at the denominator part, you have s to the power of n, where your n is greater than 1. Okay, so from the table of Laplace transform, we will choose the second one, which is n factorial over s n plus 1. Okay, why we didn't choose the first one, a over s? Because this one here is for s to the power of 1. Okay, but what you have is s to the power of n, and your n is greater than 1. So that's why you cannot choose the first one. Okay, why you cannot choose the third one here? Because for the denominator part, you have s minus a, but what you have is just variable s. Okay, so same goes for this one and this one. Although you have s to the power of n here, but this one is s to the power of 4. Okay, but this one is s squared, this one is also s squared. And as you can see here, for the denominator part, you have here s squared plus a squared, and this one is s squared minus a squared. So you cannot choose this one, all this one. Why? Because you just have the s term here, which is s to the power of 4. Okay, so that's why we are choosing the second one. Okay, so generally for the second one, Laplace inverse of n factorial over s n plus 1 is equals to t to the power of n. Okay, remember Laplace inverse of fs, you will have ft. Okay, so take a look at this one here. What you have here is s to the power of 4, and generally we have s n plus 1. So get the value of n first. Okay, so what you need to do is n plus 1 is equals to 4, and you know that your n is equals to 4 minus 1, which is equals to 3. Okay, so if your n is equals to 3, supposedly at the numerator part must be 3 factorial. Okay, and as you can see, 3 factorial is equals to 6, isn't it? So therefore you will get the Laplace inverse of 6 over s to the power of 4 is equals to t cube. Okay, so this is another one way of doing it. Okay, another way of doing it is by factorize the constant first, because in this problem coincidentally 3 factorial is equals to 6, so you have this value. But what if you are given your fs, let's say your fs is equals to, so this is another problem, okay, like say your fs is equals to 5 over s to the power of 4. So you don't have that 6 value, the value of 6. So I actually always remind my students to just factorize the constant first. Okay, so you know that you are going to find the Laplace inverse of 5 over s to the power of 4. Okay, and you know that 5 is a constant. So factorize a constant. So 5 Laplace inverse 1 over s to the power of 4. Okay, so now this is your n plus 1. So get your n. So you will have n plus 1 is equals to 4. So you know that your n is equals to 3. Okay. So by using this one, if your n is equals to 3, so your numerator part should be 3 factorial. Okay. So how are you going to do so that you will have a 3 factorial here? By do something, but you cannot change the problem. Okay, if you just times by 3 factorial here, yes, you will have t cube, but you already changed the problem, because 3 factorial is equals to 6, 6 multiplied by 5 is equals to 30, but actually what you have is 5. So what you need to do is every time you time by a constant here, you have to divide back with the same value. If you times by 3 factorial, then you need to divide by 3 factorial. Why you need to do this one? Because if you cancel out this one and this one, you will get the same problem, the same question. Okay? And student might ask, why we need to times by 3 factorial? Because if you don't time by 3 factorial, you cannot get t to the power of 3. Okay, remember t to the power of 3, the Laplace of t to the power of 3 is equals to 3 factorial over s4. Okay, so that's why you need to have 3 factorial as for the numerator part. Okay, so times by 3 factorial and divide by 3 factorial. So simplify this one, you will have 3 factorial is equals to 6. So therefore Laplace of this one, your ft is equals to 5 over 6. Laplace inverse of this one is equals to t cube. Okay, so it is much more easier for you to just factorize whatever constant that you have. Okay, then do some modification here so that it will be equivalent to the general of that function. You get it? Okay, so let's try another example. So as for this one, the first problem, we just have t cubed here, because you just have 6 factorial is equals to, sorry, 3 factorial is equals to 6, right? So that's why you don't have 6t cubed, okay, because 3 factorial is equals to 6. Okay, so the whole thing here is equals to t cubed. You might be blurred, but it's okay. We will take a look at another example. So let's say you have, for b, your fs is equals to 1 over s plus 1 over 2. So now, by looking at the table of the Laplace transform, choose which one is equivalent to the function that you have. Since you have s plus 1 over 2 here, where your 1 over 2 is a constant, right? So you will choose this one. So you know that the inverse of this one is equals to exponent a t. Okay, so generally we will have Laplace inverse of 1 over s minus a is equals to EAT. Okay, so by comparing the general one with what you have here, find the value of a. So you know that your a is equals to negative 1 over 2. Why you have negative here? Because generally is s minus, what you have is s plus. Okay, so that's why your a is equals to negative 1 over 2. So therefore, Laplace inverse of 1 over s plus 1 over 2 is equals to exponent. So what is your a? Your a is equals to negative 1 over 2 t. That's it. Okay. So take a look at the third one. If let's say you have fs is equals to s over s squared plus 16. So for the numerator part, you have a variable s. For the denominator part, you have a plus sign here. So by looking at the table of the Laplace transform, it's either this 4 function, one of these 4 function, isn't it? Okay, so by comparing what you have here, you have s over s squared plus 16. So you are going to choose s over s squared plus e squared. Okay, so generally the inverse of s over s squared plus e squared is equals to cos at. Laplace inverse of s over s squared plus e squared is equals to cos at. So by comparing the general one with the problem that you have, get the value of a. So this one. Okay, so your a squared is equals to 16, so your a is equals to 4. We just consider the positive value. Okay, so your a is equals to 4. So therefore you will have the Laplace inverse of s over s squared plus 16 is equals to cos 4t. Okay, remember in our first video of the Laplace transform, we learned on how to get the Laplace of cos 4t, which is equals to this one. So now a reverse process from this one, we will get cos 4t. Okay, So the next one, let's say you have fs is equals to 8 over s squared minus 4. So this is a constant, and this one here you have a minus sign. So by looking at the table of the Laplace transform here, so it's either this one or this one. But since for the denominator part you have a minus sign here, so you will choose this one. So inverse of a over s squared minus a squared, you should get sine hyperbolic function. Okay, don't worry if you don't have the same value here. Okay, first we just need to know what is the general form, okay, which is equivalent to the function that you have. Okay, so generally you have Laplace inverse of a over s squared minus a squared is equals to sine hyperbolic a t. Okay, so which of the value of a that you will choose as your a? It's either 8 or 4. The answer is this one here. Okay, so this is just a constant, so you can just factorize the constant first. So actually you are going to find your ft is equals to 8 Laplace inverse of 1 over s squared minus 4. Okay, remember, if you don't have the same value of a, so you just factorize the constant first, just the same as what we did here. Okay, as you can see here, you should here when you have your n is equals to 3, you know that here should be 3 factorial, but you don't have the value of 3 factorial, which is 6. So that's why much more easier for you to just factorize 5 first. Okay, so the same process here. So factorize 8, so you need to find the inverse of 1 over s squared minus 4. So get the value of a by comparing here. Okay, so you know that your a squared is equals to 4, so your a is equals to 2. So supposedly the numerator part here should be 2. So do some modification here. What will you have? You need to times by 2, divide by 2. Every time you times by a constant, you need to divide back with the same constant. Okay, why you need to divide by why you need to multiply by 2 here? Because your a is equals to 2, so you need to follow this general of fs, then only you will get this ft. Okay, if not, you don't know which one is the value of a. Okay, if you don't factorize 8 here, you don't know what is the value of a. Okay, and you cannot just simply from here without multiplying by 2, you just simply say that this is sine hyperbolic 2t. That is wrong, because for this one to be sine hyperbolic 2t, you need to have 2 as for the numerator part. Okay, so that's why I multiply by 2 and I need to divide back by 2. Okay, this is a modification that we did. Okay, but we didn't change the problem at all, because when you cancel out 2 and 2 here, you will still have the same problem. Okay, so therefore your final answer should be this one is equals to, so 8 divided by 2 is equals to 4 sine hyperbolic 2t. So this is the answer. Okay, so in my next video we will proceed with another function here. Okay, stay tuned.